Good morning. Welcome to our virtual Saturday Research Academy conference. This talk will be recorded. I will let other people go in, so please feel free to fill out the survey that I share with you on the waiting room. Let me give you one more minute so everyone that is on the waiting room can access this conference. Thank you so much for being here and welcome to our virtual Saturday Research Academy conference. Hi, good morning. Good morning, everyone. I am Dr. Elba Sepulveda, and I will be the moderator of this activity today. Our agenda for this talk is first, please fill the participant survey that I sent to you. In short minutes, I will send it back to our chat. And today we are gonna have different things going on, and please fill not only the participant survey but also the evaluation of the conference. It is very important that we collect basic information about our participants, and also we need to document what is happening here. I want you to give us an email, and collecting the email is not a bad thing. We just want to not to have duplicate forms filled out. So I'm the evaluator of the project, and I'm not going to provide any personal information about you on my report. And the reason that we are collecting this email is that we don't want duplicate submissions. If you don't want to disclose your identity, you are welcome to use a nickname like email@email.com. If I was the one who is filling it, I can use like sunflower@email.com. And thanks for, just to fill the survey. Now you will see in the agenda that we're going to have the welcome to the conference by Dr. Aratia. Then we are going to have an opening talk. I'm not sure if Dr. Ekaterina is here, but in case she is not on the presenters area or with us right now, we can let her talk at the end. Then we will have our feature presentation by Dr. Vicente Milanes, who is going to talk about autonomous vehicles. Then we will talk about the future activities and the outcomes of these activities. So if you want to stay some minutes after the meeting, you can stay. We can answer questions, or we can talk a little bit more about the topic that you are or we are covering today. So thank you so much for being here, and I will let Dr. Juan Aratia to speak to you. Thank you.
Okay. Good morning to everybody, and good afternoon to the audience in Moscow. Okay. Today we have a very interesting presentation by Dr. Vicente Milanes, as a Fulbright visiting scholar who came to Puerto Rico a few years ago, and we have been in connectivity with him for a while. He is based now in Renault Research in Paris, and I visit him because I sent some students to work in under his mentorship a few years ago. And now he is willing to tell us what's going on in autonomous vehicles. Well, Renault Research is one of the leading companies in the world developing this technology, and basically Vicente Milanes is part of this. Okay, so Vicente, the floor is yours, and welcome to this meeting, and your audience is going to be a worldwide audience. People from Puerto Rico, people from the Dominican Republic. We will have people also from Nicaragua, Chile, China, Russia. So wow, you got an international audience.
Okay.
Okay.
Okay, really good. Well, first of all, thank you, Juan, for a nice introduction. So it's always a pleasure to share time with you and your students. And today I'm going to talk you a little bit about autonomous vehicles. So I will show you which is the agenda that I was prepared for today. So first of all, I will give you just a brief introduction about which is the current situation about autonomous vehicles and the most advanced results up to today. And then I would like to enter a little bit about how an autonomous vehicle works. So there is a lot of publicity about autonomous vehicles, but I think it will be interesting for you to understand which are the different models, the different bricks that are part of an autonomous vehicles. And I will end up with a project that it was called Tornado Project that we did in France. We finished some months ago at Renault. So just for showing you some of the progress we are doing in the company in this domain, and I will end up with some conclusions in the field. So for the introduction, I recover some of the open questions from the Department of Transportation in the United States. So as you probably know, I'm probably even better than me. So autonomous vehicles is raising a lot of questions and a lot of expectations about how the future mobility will change in our lives, right? So everybody's talking about we are not going to longer be the owners of the vehicles. We are going to try to use sharing vehicles for everything. Well, a lot of expectations around autonomous vehicles with a huge market in front of us. As I was saying, so it should be the archetype of our future transportation. But there are still some open questions, right? And there are not easy response for these questions. First of all, is they will fully replace the human driver, right? So you can still talk, and we did an interesting exercise with people from the Paris region. And when they talk to them about autonomous vehicles, shared vehicles, so you can share vehicles, you don't need to be the owner, it will be cheaper. They say, well, I'm not sure I want to share my vehicle with someone, right? So I'm not even sure if I want the computer to drive instead of myself, right? So there are people that they prefer to drive. So it's still not very clear how will be this introduction of autonomous vehicles in the transportation. Then there is a second question that always came up about autonomous vehicle is all the ethical judgment. So you will probably see some studies that have been done related to this topic, like, well, if the vehicle has to decide to knock out an old woman against a baby, what the vehicle will do, right? So all this ethical judgment. Well, let me tell you my thoughts about this topic. So if the vehicle has that problem, it's because you haven't done the design properly, right? So if you guys are going to be engineers in the future, so that should be part of your design system. So you need to take that into account. So that's not a real problem for the system. It's something that you need to develop well before starting before starting to develop your autonomous systems. Then there is, of course, a third point of a lot of importance is all the impacts from the socioeconomic point of view, right? So we were talking before of people are not going to be the owners anymore. So what will be the new business model around transportation and around mobility, okay? And then, of course, something related with this idea of always using applications and all vehicles connected and all this information shared. So you probably heard before about the vehicle to everything. So connecting the vehicle to the grid, to other vehicles, to the infrastructure, to the pedestrians. Well, there is, of course, a relationship there with the privacy and security of people around. So there are still all these open questions around autonomous vehicles, but there is something before entering in the details about how an autonomous vehicle works that I would like to show you, right? So it's, of course, Waymo and previously Google is the most advanced company working in this field. They just show an announcement about a month ago in beginning of November that they say that they were introducing the Waymo driver in New York City streets. Well, they have been working for years only in Arizona, And now this announcement doesn't mean that they are going to put autonomous vehicles in New York. That means that they are going to start to record data in New York, okay, to create and to build their map. And then in probably in some months, they will start to do some testing, of course, always with a driver behind the wheel. Okay, so at the very end, what happened with autonomous vehicles is there is a lot of expectation. People from the media are showing that the advance is much more than what we have today. Okay, and even if there are significant progress in the field, it takes time to put an autonomous vehicle to work, and of course to progress in the field. So just for giving you an idea about which is the status of probably the most advanced company in the field. So I would like to explain you a little bit more. I think it will be interesting for you to understand better how an autonomous vehicle works. Okay, so I'm showing you there are plenty of architectures for autonomous vehicles, but all of them are quite similar, right? So I just took one of them for explaining you. It's always divided in different modes. First of all, is all the acquisitions, which means all the sensors that are on board the vehicle to understand what is happening around the vehicle. Then a second step is the perception system, is the processing of all this information to figure out where are the pedestrians, where are the vehicles stop around, where are the trucks, or all this kind of information. Then there is always a third block related to communication. So as I was saying before, now all vehicles are connected, and the most information you recover, the most extended perception, let's see, can have the vehicles, because you can know information in advance, even before the sensors in the vehicle can see that information. Then, of course, you have the decision. Well, once you recover all this information from the sensors and you process all this information, you need to decide what to do with the vehicle. What is your final destination? How you want to proceed? So you want to change lanes, which is the exit you want to take, and then a local planification of that road you want to follow. Then, of course, you need to control that commands that you are generating the decision, and then finally just act on the actuators on the vehicle, so the steering wheel, of course, and the throttle and the brake of the vehicle. So I will give you just an insight about what you can find in each of the model of this architecture. So I will start first for the acquisition. So which are the classical sensors that you can find in a vehicle? Okay, so that's I just took a general picture. Okay, so there are plenty of options here, but I took ones that represent most of the sensors that everybody working in autonomous vehicles is using today. So first of all, everybody relies on a GPS, on a global positioning system that is always in the roof of the car, to be able to position the vehicle within the road. Okay, this is not like the regular GPS that we have today in the vehicles. It's a most advanced system with corrections that allow to have a precision in the vehicle positioning around 2 centimeters. So that system is of course expensive. Okay, but you need that level of precision to control autonomous vehicles. Then they are always equipped, of course, with ultrasonic sensors that you have also today in the market, and they are normally used for parking maneuvers or this kind of maneuvers, and they are cheap sensors. So this is not a problem from the budgetary point of view of autonomous vehicles. Then, of course, you recover all the information from the odometry of the sensors, so all the sensors you can have in the wheels, in the steering wheel, so all the different information. And normally they are cheap sensors, but there are some companies that decide to increase the precision of. So of course, more precision always mean more a higher price. Then the different computers, okay, that you put on board the vehicle. So, and that's normally very related, okay, to the cameras that you put in the vehicle. So the more the cameras, all the algorithms based on cameras are based on the artificial intelligence. So they are more they consume more resources. Okay, so you need to increase their computational capabilities. Okay, then of course you use radars sensors, okay, to detect the vehicles around you. And finally, and you are probably aware of this, most of the vehicle has either a lidar in the top or 4 lidars in the corners of the vehicles, okay, to help to detect all the vehicles, all the vehicles and all the obstacles around the vehicle. So this is from the acquisition point of view, but there is even if you put plenty of sensors around the vehicles, there is still limitations, right, in the development of this system. Why are these limitations coming? Well, for example, for vision system based on cameras, so the weather conditions affect a lot to the capabilities of the system. So fog, rain, sun, snow, everything is affecting a lot to this vehicle, night operation, of course. So the range that is quite limited. So even if cameras are pretty good, they are not, of course, as good as our eyes, as our driver's capabilities. Then we always have more or less the same problems with all the different technologies that we are using today for autonomous vehicles. So radar, they are good, but they have a lot of problems with noise. We have also inertial measurement unit that help in the positioning of the vehicle, but they always include some drifting in their measurement. And for the lidars, is more or less the same problem with the vision. So it's working well, of course, for nights, but they have a lot of problems with heavy rain, with fog, and all this kind of conditions. So even equipping the vehicle with plenty of sensors around, they don't guarantee you to give you the main capabilities of a human driver today. Okay, and that's of course one of the limitations for the autonomous vehicles, because as you can imagine, this is the first let's say the first step in the architecture of the autonomous vehicle. So it's very important that we recover all the information with the maximum details possible. Okay, from the acquisition. So once we have all the information inside the vehicle, we need to process that information in the perception brick. What we want to say when we are talking about perception? Well, normally people include here two different capabilities. Well, first of all, recognize the environment around you, okay, where the vehicles are, where you are, where the vehicles are around you, okay, that's the two most important works. So first of all, an important task is to know where you are. I'm showing you here one of the techniques for doing that, that is based on SLAM, simultaneous localization and mapping, okay? And that gives you an idea about how the system works. So we are in this area, and on the right side, you see what the vehicle can see, okay? So you can imagine if we are in the point A and we want to go to the point B, he needs to find a route to connect these 2 points, okay? So that's the first thing, to know the environment in which you are and to be able to locate the vehicle within this environment. And then, of course, detect and classify all the obstacles around you, okay? I'm not gonna go into more details in the perception, but I think it's important to you, just for giving you an idea about how all the different demonstrations, or some of the most important demonstrations in the last 20, 30 years in the field, which are the kind of sensors they have put into the vehicles. So the first demonstrations at the end of the 80s, okay, beginning of the 90s, they were most of them based on vision systems, on cameras. Some of them include just a single LiDAR, okay? And you can see like around the 2005, 2007, they start to significantly increase the number of sensors in the vehicle, okay? So much more LiDARs, and you can see, well, it goes to 4, 5, even to 12, 13 LiDARs on board the vehicle. And the more advanced demonstration, the more sensors they are including on the vehicle. So that gives you an idea that once you start to do the first testing with a single camera in front and you detect the most relevant obstacles, when you are putting the vehicle in more complex situations, you need to recover much more information and understand much better what you have around you, right? And you need also to rely on fusion system to be able to navigate in different weather conditions. So the more sensors you have, of course, the more capabilities for understanding the environment. Okay, so you see that with the evolution of the years, the different demonstrations, they have included much more sensors on board, and of course that causes that you also have much computational power on board. Okay, even if you put all this information in the vehicle, there is still a huge problem for autonomous vehicle, and the problem is basically people. Okay, so when you are driving in an autonomous vehicle, if you have, for example, a vehicle in front of you, in the next step or in the next second, you can try to predict what the vehicle will be. So if you are driving, for example, at 50 kilometers per hour, of course, the vehicle in the next step, he will be 1, 2, 3, 4 meters ahead of you, but he cannot go backwards in 1 second because you cannot stop the dynamic of a vehicle. The problem with people, with pedestrians, is that they can go in whatever direction in whatever moment. Okay, so it's the more people you have in the area in which the vehicle is driving, the more complex is the situation for the autonomous vehicle. Okay, and just for giving you an example of this, you can see, for example, some of the videos from Waymo in Arizona, and you will see when they are driving in a two-way road when you have 2 lanes, they are always driving in the left lane, right? So they are basically doing that to try to be as far as possible from the pedestrians, okay? Because the closer you are to the pedestrian, the more complex it is to manage the situation, the more you need to brake the vehicle, and the feeling inside it's a little bit awkward, let's say, okay, if you are having this kind of interaction. So that's why it's better for autonomous vehicle to start for situations in which the interaction with people is as reduced as possible. And that also, of course, give you an insight about Tesla, okay? So if you see Tesla vehicles, they propose an autonomous system, but just for highways, right? So of course, in highways, well, you can find at any moment probably, but normally there are no pedestrians there, there is no people there around, right? So that's why it's very important, and the most complex is the area in which you are driving, the more people there, the most difficult for the autonomous vehicle. And then I also want to talk to you a little bit more about the communication. So which is the importance of the communication? I will show you this with a simple example. So let's imagine that you have these situations that you can see very clear here in the picture, right? But let's say that this is the autonomous vehicle in this situation. Well, what happens if you only have your onboard sensors in the vehicle? You can, of course, be able to position the vehicle, to locate the vehicle in the scenario. You will be able to know that there is an intersection here, but with the onboard sensors, you will only know that there is a car in front of you. That's all the information you will be able to know in advance. What you will win with the communication system? Well, this is what happened in this kind of a scenario. So even if you have buildings around, you will be able to receive the position, speed, intention, all the information for the vehicles around you. And even more importantly, you can also include some sensors in the infrastructure. So if you can imagine complex situations like runabouts or intersections that are difficult to handle, you can even put some sensors here and you will enrich the information of the vehicle with this information. So that's the main role or the main contribution of the communication system to the autonomous vehicles. Once you already receive all the information, either for the sensors on board the vehicle, as I said before, cameras, LiDAR, radar, ultrasound, so all the sensors you put in board to have a 360-degree understanding of the environment, plus the information you can receive via the communication system, you move to the decision block. So how the decision block, how the decision system block works. So basically, well, I put a first image here in the top of the slide. That well, probably you already heard about this. Is the complexity of the software in a vehicle. Okay, so if you compare that with a jet fighter or a Boeing 707, okay, you can see which is the difference of the line of codes from a vehicle. I'm only talking about a regular vehicle, not an autonomous vehicle. So with systems like cruise control system, adaptive cruise control, lane centering, just with this kind of software, you can compare the complexity of a production vehicle today. So even that we are already in this situation, we need to add much more complexity when you have to take intelligent decisions in the vehicle. So how this works normally? Well, there are 3 levels of complexity, let's say. You have, first of all, a global planning, okay? So as I showed before, you have a map of the area and you need to identify a first route to cover that area, okay? So you want to connect, I don't know, Washington with Philadelphia, okay? You can have a first route to connect Washington with Philadelphia. Once you have that level of information, you move to the second layer, that is the behavioral planning. So it's related to high-level decisions in the vehicle. So it means which is the exit you are going to take, which is the lane in which you are planning to drive, which is the speed you will have for a given straight, okay, that level of information. And then once you have this level of details, you move to the lowest level of detail, what is called the local planning. That gives you the specific trajectory on a given moment. So as I was saying before, the behavioral planning tells you, okay, I want to change lane from the right lane to the middle lane, and the local planning generates the trajectory you need to follow, okay? And that's the information that it receives for the control model of the vehicle. And it's the actuators of the vehicle that execute that action. So what we can find in the control of the vehicle. So as I said before, it receives all the information from the local planner, okay? And the information is usually divided into levels. One of them related to the longitudinal behavior of the vehicle. It means the acceleration and the braking of the vehicle. So it governs the electric machine of the vehicle, okay, for the acceleration and the braking system, and the lateral controller of the vehicle. This one is in charge of the steer the vehicle. So it's related to the steering wheel that we have that we have in the vehicle. So normally you have two levels of controls, one of them for the low level action of the vehicle to manage the different actuators, and then to command all the reference generating for the decision making system. Okay. Before moving to the Tornado project that I want you to explain you, I just want you to show you a simple example about how you can control, how you can implement the automation of a vehicle. Okay. So today, of course, the vehicles you can do drive-by-wire system, so you can control directly using the internal messages of the vehicle. But there are a lot of companies and research center that they are just putting their system on top of the vehicle architecture. So there are simple ways of doing that. I'm showing here just an example. So you have your steering wheel and you have the steering bar that is connected to that is controlling the wheel movement. So you can basically connect two gears here and control via a simple motor the movement of one of the gear, and the other one is coupled to the steering bar. So you can manage the steering actuator, so you can manage the lateral behavior of the vehicle just implementing this simple system. Okay, and you can do something similar to the pedals. Okay, so you don't need to remove everything. You can either include for the accelerator a switching system to control either the accelerator pedal or via analog signals to control the same action that we are regulating today when we are accelerating a vehicle. And for the braking system, is something similar. You can put an electro-hydraulic system, that is the example I just took for today, to put something in parallel of what the vehicle has today for braking, okay? And in that way, you can easily control whatever vehicle you have today in the market. Okay, so this is more or less how the general architecture for our autonomous vehicle works. I just want you to show you three final components, okay, that everybody has always in the architecture of the vehicle. They are very important and normally they are not explained a lot. Okay, so the first of all, and I think it's probably the more important, okay, is the database. What means the database? This is somehow related to what I told you before about Waymo. So what Waymo is doing today is trying to record absolutely everything in New York area. Okay, so what that means? That means that you have complex intersections like the one we are showing here, and in the right you can see how these intersections are mapped. So how you create an highly detailed map, okay, about the driving situation. What it means, all these different lines? Well, this means all the potential movements that the vehicle can do. So if you come here to this point with an autonomous vehicle and you want to go, for example, from this lane to this lane, okay, if there is not a given connection, okay, it's not possible to do that maneuver. That, for example, one of the classical problems when you have a track here in the middle, okay, and you don't find connections between your points, okay, the vehicle, autonomous vehicle will stuck at that given point. That's why it's so important to properly register all the area in advance of doing whatever autonomous driving test or autonomous driving experimentation today. Okay, so it's important for you to keep the idea that creating the database is fundamental today. Everybody working in autonomous vehicle is doing exactly the same, okay? Especially when you are driving in urban areas, which the traffic is much more complex. If you move to highways, as the Tesla system, you always have lane markings, everything is much more clear, so there is no pedestrian interaction, as I said before. It's easier to do something without a map, okay? But if you try to move to urban environments, you will need this kind of systems, okay? That's first thing. Second thing is, of course, the HMI. It's always important. It's always included today, and it's getting more and more complex, okay? To be able to provide the driver or the passenger, if it's an autonomous vehicle, the capability to indicate which is the final destination, if he wants to change the ambience, whatever modification he wants to do, there will be always an HMI in the interior of the vehicles. A final system that is quite important, but it's not normally very detailed in the architecture, is the supervision model. So we always have a complex architecture, as I showed before, okay? And you need always like a healthy manager, okay, to be sure that all the models are working properly, to be aware if one of the models is giving a problem, okay, and to degrade or even stop the vehicle if something is not working well. But that's the main task of the supervisory system, okay? So with this general idea about how an autonomous vehicle works, I would like to show you the last project we did at Renault in France related to autonomous vehicle. And it was a project that we call Tornado. I guess that probably you are younger than Juan and I, but Tornado is the horse of the Zorro. So he just called the horse and he just came along. So basically that was the main idea of naming the vehicle in with this name. And Juan, for your information, it was also an idea from Javier. So as you can imagine. So I will tell you more or less the idea of this project is basically we were in the area in the south of Paris. Okay. And this is very important. When you are moving to rural areas, it's not possible to have a public transport there. Okay, so it's easy to connect Paris city center because you have plenty of people there. So it's worthy the investment, let's say that way, or the government is willing to invest to provide more metros, more buses, more connection systems. But when you move to rural areas, you have people, so the density of people is lower, okay, and it doesn't make a lot of sense to put buses or to put any other system to connect this area. So we thought that it was a good idea to try to run an experimentation in this kind of situations. And what we wanted to do is in a city called Rambouillet, around 40-50 kilometers from Paris, that is here. Okay, so there is a huge commercial center with more than 10,000 people per day that is visiting this commercial center, and you have a train station that connects the commercial center to the center of Paris. Okay, so there are significant traffic here. There are people living around. Okay, but there is no enough people to have a public transport. So we thought like a solution like a road taxi. Okay, and we use our Renault Zoe in this specific test will be a good solution because you can transport 3 or 4 people. You can use an on-demand system. So we've developed an application so people can call the vehicle to pick them up in wherever point within this area, okay, and transport the people either to the commercial center or to the train station. Okay, that was more or less the principle of the project we were trying to develop in Tornado. So, what was the complexity of or the technical use cases that we wanted to solve in this project? Well, here are some of the complex areas that you can find in or that we have to face in the Tornado project. So there is one thing important is when you are moving to rural areas, it is different than when you are doing testing in Paris, for example. So if you talk with the Paris mayor, he will tell you, okay, of course, if I have to change something, if I have to change the traffic, do a new pavement, do I mean, whatever modification, they are willing to do that. Here, well, of course, the budget is not the same that in Paris. So they say, we will help you in whatever you need, but you must have, you have to develop your vehicle and the vehicle has to be able to drive in this specific situation. We cannot change that, okay? So that was an interesting challenge of this specific use case. And you can see here some of the most complex situation we have to manage. So we have this kind of left turn, okay, unprotected left turn without a lot of visibility, and people was driving around 100 kilometers per hour in the other direction. We have to enter in the commercial center that you can see is very narrow area with some slope changes, a lot of people walking around, so it was not straightforward. You can see that it was like a really narrow road. So we only have around 10 centimeters for each side of the vehicle to keep the vehicle within the lane. Okay, so that makes things quite complex. We also have to pass through this complex situation like a tunnel where we reduce from 2 lanes to a single lane, and we even have a left turn after the tunnel. So you need to manage the traffic that was coming in the other direction, okay, without any visibility. And that was, for example, a good example of using communications here. So thanks to adding vehicle to infrastructure communication, we added 2 traffic lights that were connected with the vehicles, and we were able to manage this kind of situation. That, of course, it was already really complex to manage just by a human driver, and without any visibility, it's really complex for an autonomous vehicles. And then, of course, something very that you can find a lot in Europe is the roundabouts with a lot of traffic, a lot of vehicles crossing around. Okay, so I will show you just a final video of the project with the final implementation we did for the development.
I'm sorry, this video required to have some audio on it?
Yeah, it's not working.
No, we are not hearing it. Let's start sharing that again, but yeah, at the bottom, when you share your screen, you will have a mark, a square. So mark it, and you will be able to share your audio.
Well,
When you're sharing your screen,
yeah.
stop sharing right now and share that again. And you will have, the option that you need to mark
Yeah.
for sharing the audio. Okay.
All right. Yeah. Now it works.
Yes, now,
Okay.
now it's working. Go back.
Okay. Good. So as you can see, there is a driver behind the steering wheel. This is because of the French law. So it's not authorized today to have an autonomous vehicle without someone in the driver's seat. Okay, and that's in general happened today in all the in Europe. Okay, so in terms of regulations, United States is much more advanced than Europe. So what is authorized today in the States of doing some testing without a driver behind the steering wheel is not authorized in Europe. So that was basically what we did in the Tornado project. And just for finishing my presentation, I would like to give you some conclusion. So even if you heard a lot about autonomous vehicles, the implementations to date are still limited. Okay, so as I said before, Waymo was driving a lot in Arizona. They are starting now to register New York area, and I can tell you that if they came to Europe with the plenty of runabouts, the traffic that you can find in Paris. I have an example here for the Arc de Triomphe. I will tell you that it will be impossible to put an autonomous vehicle there today. Okay, so it's still a step-by-step progress. There is something really important is the ODD, is the operational design domain. So it's rated with something that I already said before. So if you limit the area in which the vehicle will drive, for example, you can reduce the number of interactions with pedestrians. That will help you a lot in the system. And that's, of course, give you an idea why Waymo decided to start in Arizona. Okay, it's not because someone was living there, it's because there are less people living there. So that makes you think easier for starting your system. There is, of course, still a lot of work to improve all the technological bricks that are part of an autonomous vehicle. So we need to improve the localization of the vehicle. We need to, of course, improve the perception of the vehicle, and of course, the decision making. Okay, the most complex the situation, the most difficult for the vehicle to take the right decision. And finally, there is still this discussion between automated vehicles, so with still someone on board, or fully driverless vehicle, and that will of course change all the mobility paradigm and how will be the future mobility ecosystem in the short term. So that's what a little bit the talk I want to share with you today. Thank you very much for your patience, and let me know if you have any question.
Oh, thank you very much, Vicente. This has been an outstanding presentation, and I hope you see the audience will have questions. I have my question, but I will let the audience first to ask the question. So the student and the faculty, Maria, who is in China, maybe they have questions. Silent. No, Maria. Maria,
You are mute.
you are mute, Maria. Can you open your mic?
Okay. Can you hear me now?
Yes. Now we hear you, Maria.
I'm a few minutes late to coming. I bought a new computer and I tried to get in early. So I just didn't catch the whole talk, the whole PPT. I'm really interested in the system design just now, especially the detection of the hurricane and all this. Yeah, and today I also bought a new car, and it's made in Japan, and the brake, I'm not very interested in the brake, the design. So, and the auto vehicle, it's not very modern. I really would like to know something about the frontier information about the design, like using electricity as the fuel. Juan?
Yes.
Yeah. So yeah, that's what I would like to say. So please say something about the engine, the design, especially the energy. Yeah, from this side. Yeah. Is there any new invention in this aspect? Yeah, like now I saw many people using, electricity. And what are the modern energy that we can apply in our auto vehicle? Thank you.
Good.
Okay, so thanks for the question. So, well, electric vehicles are kind of a different domains, but I can give you some insights about what is happening today in Europe. Okay, so for regulation for 2035, there are no longer allowed to sell combustion engine vehicles in Europe. Okay, so all the companies are changing their offer in the coming years. So, for example, for Renault side, we have stopped to produce diesel vehicles. Okay, so we still have 2-3 years for gasoline proper vehicles, and we will have hybrid or plug-in vehicles in the coming 5 years, and all the new models are just electric ones. So for example, for this demonstration, we took a Renault Zoe that is a full electric vehicles, and it was one of the first in the market here in Europe. And now we are producing, we will start to sell in a couple of months the new Megane model that will be only electric vehicle. There will be no another different production with different capabilities, but still something I can tell you about electric vehicles. So it's very nice to have electric vehicles. I'm working on that domain. I'm also working in hydrogen propelled vehicles, but there is still a problem. When you are trying to introduce this vehicle in the market, okay, you need to have the full infrastructure for doing that. So what happened today, for example, in Spain, there is only 11,000 recharge point, okay, in Spain. That is a huge country. Okay, So that means that if you put a high penetration of electric vehicles, so you can imagine that you have 10 million electric vehicles, it will be impossible to charge these vehicles with the infrastructure that we have today. Okay, so it's not only a matter of car makers to develop fancy electric vehicles or more autonomous vehicle that can drive 400, 500, 600 miles. Okay, there is also a problem with the infrastructure. So you need to develop both things at the same time. Okay, so of course that's changing today a lot in Europe, but even if it's not changing, it will take some time. I'm not fully convinced that for 2035 we will be able to only have electric vehicles in the road. Okay, because I mean you need to also develop the infrastructure at the same time, and then, so it's not so straightforward, but it's clear that today is the trend, and from that part, okay, from the powertrain, we are fully focused in electric vehicles.
Thank you for the power illustrate.
Okay. All right.
It's one
Vicente, I had a question.
Yeah.
You see, artificial intelligence is getting into this kind of system. So can you give us a briefing, this introduction, to see which segment of artificial intelligence, how many applications you have in these intelligent vehicles?
Yeah, so it's mainly most of the development one is based on the perception system. So, and that was a huge progress that artificial intelligence caused for autonomous vehicles. So moving from heuristic system or classical algorithms to artificial intelligence based algorithms was a huge boost for this kind of system. So in the vehicle I showed you in the Tornado project, we have 6 cameras around the vehicle and a LiDAR in the top. Okay, so we were running 2 deep neural network running in parallel, okay, for recognizing of the environment, which was working really well, and the results were, I would say, really impressive. There is still a limitation on that. So the problem is you need the real data for training those systems, right? So the problem is the databases are not still there. And I will give you an example. We use some databases that were available for pedestrians, for trucks, for bikes, and for motors, okay? But at a given point, there was a guy with a horse in the middle of the road, with a horse. So of course, the database didn't include horses, so the artificial intelligence algorithm didn't recognize the horse, so we need to stop the experiment. It's just for giving you an example. So you cannot imagine the number of strange things that you find when you start to drive intensively with the system. So for me, for artificial intelligence, it's not related with the algorithms or how much you can improve the algorithms, is the data set you need in advance that has to be properly marketed, and it has to be as complete as possible to be able to recognize and understand everything in your environment.
All right, good. Thank you much, Vicente. Any other question from the audience, the student? And because the student sometimes has good ideas, okay, good images of something, all right? Wow. Wow, I think we are now moving in that direction for this, from the student point of view, all right? Yeah. Anybody from Russia? Katerina, you had a question?
No.
You don't have a question? Wow. Anybody from your group had a question? Kevin, you had a question?
I don't have a question.
Oh, you don't have a question. Yeah, yeah. Camila, she's from Chile. Camila, do you have a question? Felipe, also he's from Chile. No?
I have a question. Maybe
Okay.
it's something a little bit complicated, but do you know how to deal with I know that you are working with autonomous vehicles, but I'm just thinking about when they are using those sensors, how good are them just to locate objects like a small child or a person that is approaching or crossing the street or something like that? How do that system react to that?
Yeah, I think that that's one of the main complexities, especially with childs, right? Because first of all, as I said before, it's difficult to have databases with this information, okay? And then it's really complex to understand. So normally most of the systems are based on the capability to recognize the legs, right? Because when you are moving, you change your legs, so it's a good reference for the system to identify where a pedestrian is. But for babies or for kids, okay, or for child, it's much more complex because their movements are not as clear, let's say, as the adults. So that's much more complexity for that. And if you try to train your system, imagine that whatever thing with more or less the form of a child, you have to stop the vehicles. You will have problems with potholes, with signs, with a lot of things that will be somehow similar to childs. You will say, okay, I'm gonna stop the vehicle. The behavior will be a little bit awkward. And that's something that we already experienced in the past, in 2010, 2012, in some experimentation I did across Europe before joining Renault. People didn't feel comfortable when those things arrived, right? Because with all the news and everything you heard about autonomous vehicle, when someone go on board a vehicle, they expect that the vehicle drives at 100 miles per hour. They are moving around the traffic super fast, and that's not the reality, right? Because you need to be somehow conservative and try to design your system with your trade-off to try to be as fluid as possible in the behavior, but you also want to avoid any problem with, as I said, well, with pedestrian, childs, and those kind of situations. And that's also related with the operational design domain I mentioned before. So you need to identify where you want to put the vehicle, try to minimize those risks in advance, okay? So not go in front of a play school probably for the first testing you are doing, and that will help you to start to build up your systems, right? So today that's still one of the complexities, and the database are not well, they are not with the full information for those kind of systems.
Good.
Thank you.
Yeah. Elba, can we have a picture of the audience, because it will be interesting to have a picture of we have 24. I have 24 names here. Can everybody just show
Sure.
us their faces just for a little while? So we are going to take a shot. Okay. Yeah. Open your camera, please. All right. For just a minute. Yeah. Yeah, we are just getting. Maria, we need your face, Maria. Yeah. Jorge, Mario Sevilla, Yanira, Leila, Melissa. We need your faces for just a minute. Okay. Yanira. All right. Elba, this is good enough? Yes.
I think so.
Perfect.
But if the camera is not working, it's okay. So I'm gonna take the picture now.
Okay. All right. Okay, thank you very much, guys. I really appreciate. Yes.
Just wait, because remember that we have so many people here.
Yeah.
So I will need to make another image.
Another image?
Yes.
Good. Yeah, I would like to say a few words for the audience. Yeah, this will be our last talk of the year. We are coming back. We are going to have a break here, a Christmas break that will go all the way to the 21st of January. The 22nd of January, we will meet here, and we are planning to have a scientist from a Fulbright visiting scholar from Japan. But that's in the planning, that he will talk about neural engineering. So we are going to go back to the brain again and just trying to understand what's going on there. Okay, that is really interesting stuff. So I wish you guys a happy holiday, Christmas, Merry Christmas for everybody, and a very wonderful New Year. Okay. Well, this is Vicente. We have here a lot of students who are working in a very interesting project, and this talk are just to motivate them, open their eyes, what is going on in technology, okay, in STEM in general, okay. But we have several very interesting talk like you did today, you see, and the students really have a very good feedback with respect to the talk. So we are going to have a survey, and I'm going to show you the survey because the surveys Vicente talk about how you did it and how your message got into them in terms of knowledge, in terms of decision, and probably for the future, because we are talking here with the next generation, all right? And if we guide them correctly, well, they will pursue, you see, advances in all areas, and that's what we are talking about. All right. So Merry Christmas, guy. Happy New
Don't
Year.
go, don't go.
Okay.
Thanks to Dr. Vicente Milanes for all the information that you have been giving to us. And also, I think that we have, I don't know if she is here, but first we need to do the verification of attendance. And another thing that I have on the schedule is Ekaterina Prokofieva. I don't know if she arrived, but she wanted to say something about geoinformation systems. And I want to give her, the space to talk.
If she's here, because I didn't
If
see
she's
here. If she's here or not. Ekaterina? I didn't see her. Also, I didn't see Leonid. Okay.
Okay.
Okay. All right.
So anyway, I wanted just to acknowledge that she wanted to talk today also to the participants. And if it is okay for you, remember to the participants to fill out the survey. I know that we have some trouble trying to put it available, especially for people that are in other countries that sometimes they block the access to Google Apps. So if you are in a place that you are not able to see the URLs that I am posting, just let me know and I can send you or show you another way to fill them out. I want to thank our sponsors, the Citizen Diplomacy Action Fund, for allowing us to do this kind of activities, and also the Scientific Caribbean Foundation for this wonderful idea of having presenters all the weeks. Now I'm gonna put the verification of attendance, and after you take a screenshot of these, we will have some ideas of other activities that we can do or we are planning. Is it okay? Give me
Yes.
a thumb up if you already took your screenshot. Thanks. Okay, perfect. So I see some people that are taking the screenshot.
Good.
Thank you so much for being here. And another thing that I want to talk to you about is that the agenda that we have for this Saturday Academy. The Dr. Aratia was talking about what is going to happen during these days. I don't know if he wants to say something, but I would take first the word to say that we are planning something for January 15. It's not part of the Saturday Academy. It is called Hour of Code. It's not listed on the agenda, and I will be glad to provide information about this activity that we are planning. Aratia, do you want to say something more?
Oh yeah, yes. I think yeah, we are running other project, and Elva is and we are involved. Is generating, you see, knowledge for a kindergarten and elementary student. So in artificial intelligence. Okay, so that's very interesting. So we are going to have a meeting on the 15th, January 15th, So we are going to send you the link if you are interested. Wow, perfect. So
Yes,
this will be
and
it's a code night. Basically, this is a national, program in United States. And really, we would like to just push forward, okay? We need people, we need mentors, okay? People who are really with the knowledge of computers that can show you, see, there is a lot of material out there in the web that is related to this level, okay?
right, and we want you to invite people for this activity. You can invite your teachers from your school, but we want you to join us with a young family member, because having small children going with us in these activities will be very helpful. It is programmed for January 15, 2022. And the idea is to run the code hour. This is a worldwide activity. It's not something that we invented. It's from code.org. It will be conducted in Spanish, English, and beyond. I'm saying that it is conducted in Spanish, English, because we want to have somebody speaking in Spanish. I will try to do the translations in English so we can have both support and beyond, because the webpage can be translated in different languages, like 45 different languages, as you see here in the presentation here. You see 45 languages, and we want teachers and young people to join us for that, just to work in something about computer science, and you will see how those activities are connected to your research project. It is very, very good, because the websites we are using, they will have not only the activity that we are gonna present that day, but they will have more activities, and you may want to connect with this young user, like your cousin or your small brother or sister or anybody that can be with you that day. But if you don't have a young people, you can have another person from your family to join us, okay? It is that this activity is intended for all.
Perfect.
We will
Great.
send you the link for the registration. And if you have questions, just ask us about it, and we will send you more information about it.
Perfect. Thank you very much, Dr. Sepulveda.
You're welcome. And I don't know if you want to say something more, because you know, this Christmas season required that we stop you know, sharing activities and doing some activities during the weekend, and spend some time with family. So I wish you the best. Yes, I wish you the best, and do good with people, and enjoy your holidays.
Perfect. Yeah,
Thank you
I
so
think
much.
I already say something in terms of wishing everybody a Merry Christmas and a Happy New Year. And yes, it's a family time. So now, one way or another, we just disconnect a little bit of these meetings, but we will be focusing in the next year and finishing the project that we have in front of us. Right? All right. So see you next year, and wish you the best. Right?
Thank you.
Maria, do you want to talk? Maria.
And Marisol also wants to talk. We are
Oh.
not hearing Maria.
Which Maria?
Maria,
Man-
the only Maria I know. The only Maria I know.
Last week there's another Maria.
Ah, there is another Maria. Maria Sue. Okay.
Yeah.
Maria Sue.
Yeah,
Maria. So
Juan.
how are you?
Yeah.
How you doing, Maria? Yes.
I just got the promotion. I
Yes.
wrote you the letter, and
Congratulations. Maria.
recently these days I'm writing I'm